this video, we'll talk about how we can extend the use of stoichiometry to talk about other things related to chemical reactions and the amount of products that they produce. And so one of the first wrinkles that we can look at is something called yield. Now, when it comes to yield, there are two different types of yield that we can consider. We can consider a theoretical yield. A theoretical yield is really just another way of saying the stoichiometry of that particular reaction. So in stoichiometry, we calculate the theoretical yield, that is the maximum amount of product that can be produced given the amount of reactants that we've made. Now, theoretical yield often differs from actual or experimental yield. And this is the actual amount. This is, so I take that 30 grams of reactant A and that 20 grams of reactant B, I put them together, and how much product do I actually get? That's my actual yield, or my experimental yield. And generally speaking, this yield is going to be less than the theoretical yield. We're always going to get less than what we expect. And that's just because the chemical reaction is going to do, there are going to be side reactions. Not all the reactants are going to be reacting completely efficiently. Lots of things can go into it. But we can express the relative rate, the relative yield of a reaction by calculating percent yield. And percent yield gives us this ratio as a percentage, comparing the actual yield to the theoretical yield. And so we can see here that we have the actual yield in the numerator, theoretical yield in the denominator. And so if we take the ratio, if we divide those two, that would give us a decimal. And then we multiply that by 100% to turn that decimal into a percentage. And so depending upon the chemical reaction, experimental yields, percent yields can be, up near 99% for things that are really, really efficient, or things that are inefficient and have a lot of side reactions, purity issues. You can have things that go in the 30 to 40, 50% range and still be considered actually successful chemical reactions. Context really is the master here. So let's take a look at an example. In this example, we have 18.2 kilograms of ammonia being produced by the reacting of a mixture of 6 kilograms of hydrogen and an excess of nitrogen. The question here is, what is the percent yield of the reaction? Now, to calculate this, we're going to need to do stoichiometry. The stoichiometry we're going to do is to calculate the theoretical yield, since we've already been given this. This is our actual yield. This is what is given to us in the chemical equation, in the chemical if we did this actual reaction. So if we start with our 6 kilograms of hydrogen, and again, just like we did in the previous problems, we have to convert the kilograms into grams. And then now that we have grams rather, we can turn those grams of hydrogen, 2.016 grams of hydrogen for every mole of hydrogen. And using the balanced chemical equation, 3 moles of hydrogen equates to 2 moles of ammonia, and 1 mole of ammonia equates to 17.03 grams. And then finally, we're going to have to input one more conversion. 1,000 grams of ammonia is equal to 1 kilogram of ammonia. And so let's draw in our lines here just to show that these are all fractions. And let's pull in our calculator. Now, one thing that we can notice, we have 1,000 grams in the numerator and 1,000 grams in the denominator. So those effectively can cancel each other out, at least from a numerical standpoint. So I have 6.00 multiplied by 2 multiplied by 17.03 divided by 2.016 and divided by 3. I get a theoretical yield of 33.8 kilograms. So this was what I would have expected if all of the hydrogen had fully reacted. To get my percent yield is equal to actual yield over theoretical times 100%. So let's put the real numbers in there now. My actual yield was 18.2 kilograms. My theoretical yield was 33.8 kilograms. I'm going to multiply both of those by 100%. So bring in the calculator once again. 18.2 divided by 33.8. And so that would be my fractional yield. We sometimes refer to that, especially in engineering, as efficiency. So this particular process is 0.5, has an efficiency rating of 0.538. But we're interested in percent, so I need to multiply that by 100. 53.8% is my yield. So you would look at this, and based on some of the labs that you've done in our laboratory, this would actually be a pretty poor yield. But for this particular process that requires extremely high pressures and sometimes considerably high temperatures to get to run even a small bit, this is not bad. So that's the idea of percent yield. In the next video, I'll talk about the last wrinkle in our Chapter 7 discovery, and that is with limiting reactants.